In the next series of videos, we're going to be covering the concepts and Excel functions covered in Module 9 of your Excel workbook. If you open up the Business XLSX, which is the data file that the book uses to demonstrate some of these concepts, you'll see that it has several worksheets at the bottom. Basically, the scenario is somebody is creating a business plan, and a lot of the information is filled out, like the required expenses and assets or startup assets. We're going to be looking at some loan scenarios, and so that's this sheet. We'll start with this, taking a look at the PMT function, the future value, the NPER, the present value. I'll demonstrate the rate function. And then in the next video, we'll take a particular loan scenario and actually create an amortization schedule. And so in doing that, I'll show you the CUME IPMT and the CUME PMT functions. We'll look at the profit and loss sheet to demonstrate how to interpolate, to have Excel interpolate between two values to fill in the rest of these. And then we'll do an extrapolation where we'll take a value and then extrapolate for future years. Finally, very easy to use, but I'll show you how to use the straight line and declining balance depreciation functions. And then we get into what's called net present value and internal rates of returns. So basically, if you are making payments every year that are different, I want to know what is that net present value of that series of payments and what would be the internal rate of return. What's the interest rate basically that provides a net present value of 0. So right now, this video, let's just take a look at the loan scenarios, and you can follow along in your book. We're basically in the first section. And the scenario is that this gentleman can get an interest rate of 5%, and he wants to get a $450,000 business loan. He wants to pay it off. So if you pay off a loan, it has no future value, right? So that value is 0. And he wants to do it over 10 years and 4 payments per year. And so how many payments is that? Well, the math is already done here. I should have deleted that. But basically, you're taking, it's a 10-year loan. And in this case, it's 4 payments per year. Now, very often loans are monthly, in which case that would be 12. But here we're doing quarterly payments. The annual interest rate, basically this formula is just pointing back at the cell that contains the interest rate. What is that rate per quarter? So all you need to do is take the annual rate and divide it by how often you're making payments. So in this case, it's 4. If it was monthly, it would be 12. So we're just taking the annual rate divided by 4. On our last midterm, we had a scenario where we were taking the annual rate and dividing it by 12. Finally, we can calculate our quarterly payment. So that is the payment function, PMT, parenthesis, and I want several things. 2 of these things are optional. That's what the square brackets means on that tooltip. And that's going, well, what interest rate are we dealing with? So because we have it already divided, the annual divided by the number of payments, I can go ahead and click on that cell. And then how many periods are there in our loan? Well, that again is the years times the number of payments per year. Well, we already have that calculated, so I can just click on that cell. And finally, what is the present value? What money do you have today? And that's the money that the bank handed you. So that at the end of the day, the bank handed you $450,000. Now, of course, you're going to pay that back in the future, but right now, that's your present value. Will this loan have a future value? No, your intention is to pay it off. So if you want, you can put a 0 here. It's optional. And the type is, are you making your payments at the end of the period or the beginning of the period? We're going to follow the convention that end of the period is what we do for loans. And if we're making investments, monthly investments, we'll do that at the beginning of the period, like we're saving for in a 401k or something. So that's also 0. Now you'll see in the book, and I'll do this a lot, because both of those are optional, rather than putting 0, 0, I just don't fill them out. And that's the default setting is 0, 0. So I'm okay with that. And so now it shows our payment of $14,365. If you're following along in the book, you'll recognize that that number is way different than the number they got. And I just now see that the number of years for the loan in the review is 5. not 10. So obviously you have to pay it back twice as fast. So now our payment is $25,565 or $569. Now, of course, it's negative, and that's a convention in the business world that if money is leaving your pocket, then it's $25,569 negative. Okay, if you want to make it positive, which we don't in this case, but I've demonstrated before that you just put a negative sign in front of the payment function, and that'll make that positive. But we do want a negative because that is following the convention that as a business owner, I'm receiving $450, so that's positive, and then I'm going to be spending this much every quarter, so that would be negative. So now, if you follow along in your book, the problem is the guy doesn't think he can afford that quarterly payment, and so he wants to make a payment of $20,000 a year, or quarter, I mean, and we want to know how much balance will be left at the end of the 5 years if I make a smaller payment. So I'm going to put negative $20,000 here. That's the payment he can make. Now we want to calculate how much of this loan balance would be left at the end of 5 years if we made that $20,000. Before I do it, I will hurry up and take this cell, the 5%, and we want to divide it by, that's the annual percentage rate, so we need to divide it by the 4 payments. So there's our 1.25. So what function will help us figure out the future value, the future balance of this loan if we make a payment of $20,000? Well, they're helping you out with a little hint here. It's going to be FV, future value. So FV, but all of these functions have the exact same parameters in them. It's asking, well, what interest rate are we dealing with? Again, you want to make sure you're dealing with the apples and apples, right? So we want the quarterly interest rate, not the annual. How many periods are there if you're paying quarterly? Well, that's the 20. We've already calculated that. And then what is your payment? Well, it's not the $25,000 because we figure we can't afford that. We just want to spend the $20,000 as my payment. Now, do we need the present value in this case? Yes, we do. So we're going to go ahead and put in, I'm going to hit a comma here, put in the present value of $450,000. And the type is optional, but again, we're going to do end of the period. We'll put a 0, and now we'll close up that future value function. And it says if you make a $20,000 a quarter payment for 5 years, at the end of the 5 years, you'll still owe $125,000. All right, so then the scenario continues on. The guy goes, well, that's a bummer. All right, how many years would it take to pay off this loan if, again, my payment was $20,000? So rather than have a balloon payment, let's take a look at just paying it off. Now I need to make that negative again. And the rate, let's just copy this formula down. So basically the annual divided by the quarterly payments. What function will help me calculate the number of years? So we have a function called NPER, which basically is the number of periods. Okay, so we'll use that function equal NPER, and guess what it wants? The exact same things, all right, except this time it's the rate. Again, we got to keep it like kind, so we're dealing with quarterly interest rates, comma. What's my payment? It's the same $20,000 that we think we can afford. What's the present value? Well, it was the money the bank handed us the day the loan was closed, so $450,000. Is there going to be a future value? No, because the idea is we're going to pay this off. We're just asking the question, how long will it take? How many periods will it take to pay this off? So that'll be 0, no future value in this case. And then, of course, the type, sticking with the 0, close up that function. And it basically says you're going to have 26.58 periods. So then to finish this line, they're asking, well, how many years is that? So how did we get to years? We basically took the 5 times the 4, right? So if we wanted to calculate the years, it would be whatever this number is times 4 equals 26.58. Well, in this case, we're just going to take equal the 26.58 and divide it by 4. And of course, we'll end up with some fractional number of years. But basically, it's going to take over 6.5 years to pay off that loan at the $20,000 rate. All right, we're almost done. So now the scenario goes the same thing. The guy goes, all right, I can only afford $20,000 again, My interest rate doesn't change. And in fact, we're going to add a scenario where we calculate a rate here in just a second. But right now we're sticking with the 5%. So there's my quarterly rate. And the question is, all right, I want to pay it off in 5 years at four quarters per year. I can only afford $20,000. How much of a loan can I get? How much of a loan can I get if that's my payment and I want to get it paid off in 5 years? What function do I use? The present value. What is the present value that I will get based on these loan parameters? So we put equal PV. And when you hit parentheses, guess what it wants? The same things. The rate, the number of periods, the payment, future value, and type. What's the rate? 1.25. We're using a quarterly rate. How many periods? We're trying to pay it off in 20 periods. That's 5 years. What's my payment? Again, the $20,000. Is there a future value? Nope. I'm trying to pay this off. That was the whole point. I'm paying it off. No future value. And the type is 0. Parenthesis, and we're done. So we hit enter. Then it says, wow, if you can only afford that for a 5-year loan, that's how much money the bank can give you given that payment. And then I think finally the book goes through and says, well, the guy actually thinks he can afford $23,000. And so you type that in there. Oops, it has to be negative, because it's money coming out of your pocket. And then your loan is $404,000 is what you could afford if your payment was $23,000. So that's kind of cool. Now let's do one more scenario where maybe we're going to ask the question, what would the rate need to be in order to make a certain payment? So I stopped the video and just added a brand new line where we're going to get a $450,000 loan, no future payment, and we're going to pay it off in 20 periods, right? 5 years. And again, we're going to make that same $20,000 payment. But the question is, what would the interest rate need to be in order to make that work? So the function we will use was, equal rate. And guess what? Same things again. It's going, well, how many periods are we going for? Well, the answer is 20 quarters. Remember, let's keep it quarterly. And what is your payment? We're going to make the $20,000 payment. What's your present value of the loan? It's $450,000 is what we're hoping to get. Are you going to pay it completely off? Yeah, so there's no future value. And our type is 0, and we won't really deal with the guess. Sometimes you can start it out by telling it an interest rate to get close to. We're not going to mess with that. It's optional. You can see the square brackets. We're closing up the rate function, and we'll hit enter. Now, of course, it says 1%, and you're like, what? Don't forget formatting. Let's add some zeros to that. So that is the quarterly interest rate. How do I need to do if I want to calculate that into an annual interest rate? I'll have to divide that by, or not divide, multiply that by the number of payments per year. Now, I probably should have thought through this example a little better. We ended up with a negative interest rate. You're like, what? It should be a positive number, right? An interest rate. Well, my numbers are a little goofed up in that I'm trying to make a $20,000 a quarter payment. How many payments am I making? 20 of them. If you multiply those two, I'm going to be contributing $400,000, and that's at a 0% interest rate, right? If they just give me the money for free and I'm making $20,000 payments, I can only get back $400,000. So basically, there's no way to pay off. No, there is no interest rate that allow me to pay off a $450,000 loan. Basically, at a negative interest rates, the bank's paying me to take the money. So in order to make this work a little better, I'm going to change my loan amount to $375,000. And now we end up with a very low interest rate at 0.62%. That payment would pay back a $375,000 loan. If I make this 350, 1, 2, 3, then there's a 1.31% interest rate. Now remember, that's a quarterly interest rate. So how do I turn that into an annual rate? I'm going to take my quarterly interest rate, 1.31, and then multiply it by how many payments per year. And so there it is. I'll do my format painter. So there's a 5.23% annual rate. $20,000 will pay off a $350,000 loan. But anyway, I don't think your book shows the rate function, but that's how it's used. It's to help me calculate an interest rate that will help me achieve my objectives, a certain payment and a certain loan for a certain period of time. So these functions all use the same parameters. It's rate, the number of periods, the payment, present value or future value, and then the type for loans, we're always doing 0. And so it's just a matter of, as a student, knowing what each of these things mean, making sure that I get the right rate. It's probably the quarterly or monthly rate, the right number of periods, the payment is a positive thing or a negative number, the present value is a positive number, and then using any one of these functions to calculate the part that you're missing. And that's it. They're not hard to use. So that's it. We'll end this video here, and I'll create another one showing how to create an amortization schedule showing what the loan looks like as we pay it back every, in this case, quarter.